Have you ever heard of stars that explode every 80 years and still don't die? We are about to witness a unique space explosion that is visible from everywhere. Unlike a supernova, in which stars burn up completely in a gigantic firework display, an old star can also produce so-called nova explosions. The spectacle is similarly worth seeing. And we don't just see it once, but again and again. A nova in the Corona Borealis system is about to explode, and we are excited to see it. Many people dream of seeing a nova with the naked eye from Earth. Novas are huge thermonuclear explosions that light up stars 1,500 times brighter for a short time. We will probably see the upcoming nova as one of the brightest points of light in the night sky for weeks. This is great news for space fans. This astronomical treat really doesn't come along every day. Corona Borealis explodes about every 80 years, most recently in 1946, and now it's about to happen again. This celestial explosion promises to be one of the brightest and most striking celestial events of the decades. A nova occurs when two stars in a binary system interact with each other in a bizarre way, releasing a huge amount of energy. This then leads to an explosion and a sudden increase in brightness, so that a new star appears in the sky. Novae are not only fascinating to observe, but also highly interesting from a scientific point of view. It's sometimes unbelievable what happens in our universe, and anyone who knows the true background to novae will be amazed. Is a nova really a star birth? You probably all know the origin of the term nova. Nova comes from Latin and means new. Tycho Brahe, the famous 16th century Danish astronomer, coined the term when he suddenly observed a new, very bright star in the night sky. He called this phenomenon stellar nova, new star, or later just nova for short. For him, with the technical possibilities of the time, it really did look as if a new star had been born. However, what the astronomers observed at the time was not the birth of a star, but a violent eruption with a subsequent thermonuclear explosion in an existing star system. A nova is actually a rather short but extremely bright flash of a white dwarf star. White dwarfs are formed when stars the size of our sun have used up their fuel supplies. Instead of exploding, they lose a lot of their size and shrink. White dwarfs, which exist in binary systems, can then have the property of sucking matter from their partner star. As soon as a critical mass is reached, the explosion occurs, which we can then see as a nova. The difference between a nova and a supernova is simple. The nova is formed in a binary system, where a white dwarf accumulates matter from a companion star. The white dwarf is not destroyed by the explosion. It can even produce several novae over thousands of years. Supernovae are much more intense events in which a star is completely destroyed by the explosion. Type 1a supernovae are special features that are similar to simple novae. Once again, a white dwarf is involved. However, in this case, the white dwarf accumulates so much matter that it no longer survives this final explosion and disintegrates. The brightest supernova brightnesses are those of type 2, in which a massive star with at least 8 solar masses collapses at the end of its life. The brightness of a nova is impressive, but it is much fainter than that of a supernova. What we will soon see is a simple nova of a small white dwarf, which will not perish in the process, but will give us a great light show. When the time comes, the white dwarf will show a sudden increase in brightness of more than 1,000 times. Such events are usually only visible with telescopes. But in this case, the nova is so close that we can see it with our own eyes. Basically, the brightness of novae and supernovae that we can see from Earth always depends on the distance, on how far away they are. A nearby nova can appear brighter to us than a very distant supernova. The next supernova visible from Earth will be the explosion of the star Betelgeuse. Researchers do not yet know exactly when this will be. Perhaps tomorrow, perhaps not for a few thousand years. However, we will certainly see the nova of the white dwarf Corona Borealis, and the next one will almost certainly come in 80 years. Perfectly visible despite being 3,000 light-years away. It's actually incredible. T Corona Borealis is more than 3,000 light-years away from us, and yet we will be able to see it very well with the naked eye. The binary system is located in the constellation Corona Borealis. This white dwarf is an extremely dense, compact remnant of a former sun-like star. After the original star had used up its nuclear fuel, its core collapsed, the outer layers were ejected, and a white dwarf remained. The companion star from which the white dwarf is extracting material is a red giant. This star is also nearing the end of its life and has begun to expand. These outer layers are gradually attracted to the white dwarf and accumulated until the conditions are right for a thermonuclear explosion. This explosion will then dramatically increase the brightness of the white dwarf and give us a nova. According to predictions, the nova will reach a brightness of about 2.5 magnitudes. This means that the apparent new star will then be one of the brightest objects in the night sky for a few days or even weeks. Even if you live in the city and in places with high light pollution, you will be able to see the bright spot in the night sky with the naked eye. The constellation Corona Borealis is also referred to as the Northern Crown on some German star charts. You can easily find the constellation because its semicircular shape makes it really easy to recognize in the northern sky. It lies between the two somewhat better-known constellations of Botus and Hercules. If you look between the two, you'll see some very bright stars forming an arc. This is the Corona Borealis. The brightest star at the top of the arc is Alphecca, sometimes referred to as Gemma. From Alphecca, you can easily trace the other stars of the arc and easily recognize the entire constellation of the Northern Crown. It's best to look in that direction now and memorize the constellation. After the explosion, a very bright new star will be visible there. This is the nova. The best time to see the nova will be late in the evening when Corona Borealis is high in the sky. A thermonuclear catastrophe every 80 years? It's crazy. We're enjoying a fantastic glow on Earth, and a devastating inferno is actually taking place in this world 3,000 light-years away. The impending nova in the T Corona Borealis system is an event that occurs in a certain sequence every 80 years. The first known eruption of the T Corona Borealis was observed in 1866. During this time, a bright star suddenly appeared in the night sky, which was noticed and recorded by many astronomers at the time. This phenomenon was repeated in 1946, exactly 80 years after the first observation. The 1946 eruption was studied in even greater detail by astronomers worldwide. Further historical reports by an abbot named Burchard von Erzberg from the year 1217 show that the nova has been a companion of mankind for a very long time. Erzberg noted an unusual brightening in the region of Corona Borealis. In recent years, astronomers have observed increased activity in the T Corona Borealis system. Since 2015 and 2016, there have been repeated, unusual variations in brightness and a dramatic increase in radio and X-ray emissions. Both are clear indications of an imminent eruption. The observations are also similar to the activity documented by astronomers during the earlier eruptions in 1866 and 1946. As early as 2018 and 2023, there were remarkable fluctuations in brightness that made researchers sit up and take notice. They compared their documents with the data from 1946 and found astonishing similarities. These recurring signs almost certainly indicate that the next nova will occur in September 2024. Then we may see a light that is one of the brightest in the night sky for a few weeks. This white dwarf will probably produce many more novae after this explosion. It may take millions of years before it collapses completely or triggers a Type 1a supernova. We don't know the exact number of possible novae. We have not been observing the phenomenon long enough for that. Scientists have calculated in simulations that the quantity and periodicity of novae depends on several factors. In addition to the amount of accumulated matter and the efficiency of the accretion process, it's the rotations of both stars as well as the discrepancies that the two have on each other. In a periodic nova system such as T Corona Borealis, the white dwarf continuously attracts matter from its companion star, a red giant. and this matter then forms the accretion disk. The mass slowly reaches the surface of the white dwarf. Now, of course, the question arises as to why this sucked-in matter then explodes. The accumulated matter on the surface of the white dwarf consists mainly of hydrogen. When the mass of this hydrogen layer reaches a critical density, thermonuclear reactions begin. The reactions release enormous amounts of energy. Think of it like a giant hydrogen bomb. When it goes off, there is a sudden explosive brightening and the nova becomes visible. We are looking forward to even more novae. Systems with white dwarfs and red giants are such extreme places that they are certainly no longer inhabited, so we can continue to innocently enjoy the beauty of novae. While all eyes are currently on T Corona Borealis, we can announce that there will soon be more novae in other star systems. Another periodic nova system is RS Ophiuchi, which consists of a white dwarf and a red giant. The last eruption occurred in 2006, and as this system has a periodicity of only about 20 years, we will see the next nova as early as 2026. In the U-Scorpii system, there is a bang every 10 years. But since this system is 47,600 light-years away from us, you'll need a good telescope to witness the next beacon spectacle. Click on subscribe now and look forward to new video hits all the time.